Hello and welcome. Today we are taking a look at problem 33, Leetcode 33, search in rotated sorted array. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to your function, nums is possibly sorted at an unknown pivot index k. 1 is less than or equal to k, less than nums.length, such that the resulting array is nums of k plus 1, and so on, and then nums of n-1, nums of 0, nums of 1, and so on, and nums of k-1, 0 indexed. For example, 0, 1, 2, 4, 5, 6, 7 might be rotated at pivot index 3 and become 4, 5, 6, 7, 0, 1, 2. So given the array nums after the possible rotation and an integer target, return the index of target if it is in nums, or -1 if it is not in nums. You must write an algorithm with O log n runtime complexity, and here we have some examples. So we have this array here, 4, 5, 6, 7, 0, 1, 2, and target is 0, and that is in the array, so we return 4, index 4. And then target 3 is not in the array, so we do not return the valid index, we return a -1, and so on. As you can see, the expected runtime complexity is O of log n, and that means that we want an algorithm that is better than linear in time. And when you see an O of log n algorithm, that usually means binary search, right? Because we divide our search space in half each time we advance. So how would we approach this problem? Well, it's more complex than regular binary search. So let's go to the drawing and see what we can do on these examples. So we have the two given examples from the beginning, 4, 5, 6, 7, 0, 1, 2, with the target 0 and the target 3 in the second case. So if we take the midpoint, it's going to be at index 7. We're going to have here midpoint, then we're going to have the left side and the right side. Okay, and now we ask if our the nums of L or left is less than the nums of mid. So if that is the case, then it means that the elements are sorted on the left side of the array. And if that is the case, which it is, we search if the element 0 is between 4 and 7. And we can see that 0 is not between 4 and 7, so that means we need to go right. It's not in this portion of the array. So then our left pointer is going to be moved over here to the mid +1. Okay, and now we ask again if our we take a new mid, and we ask again if the first element is less than equal to mid, and it is, so it's sorted. And then we ask if 0 is between 0 and 1, if it's in this range, and yes, it is. So in this case, we move the right pointer to mid -1. So we move the right pointer to mid -1, which is equal, left is equal to right, and then on the next iteration we check if target is equal to our new mid, which is going to be the same element as with index 4, so that's target 0. So we found our result here. So we return the index of this, so we return 4. Okay, and then for the next example, we again check if our array is we take the midpoint. So 3 is not in the array, it's just there as an example because that's the target. And we take the left side and the right side, and we check is 4 less than 7, yes, so this portion of the array is sorted, so the rotated index must be on the other side. And then we check if 3 is between 4 and 7, and no, it isn't. So we go on the right side of the array again at mid plus 1, so here, and we remove the old mid and we create a new mid here, and we ask if 0 is less than 1. It is, so it's sorted. Well, is our target between 0 and 1? No, it isn't, so we go on the right side. So we go with left is mid plus 1. So we are now at the last position. Left and right are equal, and our midpoint is going to be pointing to the element 2, right? With the last index, which is index 4, 5, 6, 7. But the problem is that the element is not equal to target, so we return -1 instead, because this element is not 3, right? And there are no other elements. We've reached the end. Okay, so let's do the code. Let's go to the code and see how this looks like. Alright, so first of all we have to define our left and right point. So left is 0 and right is nums of size -1. And since left and right can be the same position, we want to go less or equals to, while left less than or equals to right. Then we compute the midpoint, and to compute the midpoint we are going to use this formula such that we do not overflow. So you could do left plus right over 2, but this is safer. And then the first thing we check if nums of mid is target, we return mid, right? We return the index. Okay. If, however, that is not the case, if nums of left is less than target and target is less than the mid, what does this mean? It means that the target is in the left sorted part of the array. So then right becomes mid -1. But one more thing before this, we want to make sure that our array we are in the left sorted part of the array. So we want to say, okay, if nums of left is less than nums of mid, so we want to be in a sorted part of the array if possible. So that means that the rotate index is not in this part of the array, right? It's not until mid, but it must be greater than mid. And then else left is going to be mid +1, target in right part of the array. And else, that means that the right side is sorted. So if target is greater than nums of mid and target less than or equal to nums of right, here we do the opposite. So we go left is mid +1, and otherwise right is mid -1, right? So we do the opposite. We're on the right side of the array, and if the target is in that right side, we go towards the right. Otherwise we go towards the left. Okay, and that's it, I think. While left as in right. Then just return -1 if we haven't found anything. Let's see. Accepted for this test case. And accepted. Time complexity of login. So you see it's using binary search. For the memory we are not using anything extra, so it's over 1. We're just using the given input array. Okay, so that was it for this problem. I hope you liked it. If you did, please like and subscribe. And stay tuned for more C++ problems. Thank you and bye.